So as long you are to work with your exponents, logarithms, all you need is the laws, like I have explained before on the introductions of each and every part. On question number 4, we were given use logarithms on 4.1. So this part, you are supposed to use logarithms to find the value of the following. All right, so 4.1, that is what you're supposed to have. Show all steps. Answers only are not acceptable. Meaning to say, we could have simplified this direct on our calculator. All right, I want us to see this part. We could have simplified this direct on your calculator. This is your calculator here. All right, so what I'm just going to do is to fix this calculator to 3 decimal places. All right, so I'm just going to round off to 3 decimal places like this. X is equal to this. That is 44,6 like this to the exponent of a 4. This is over. We are going to divide to the cube root, that is shift the cube root here of 798. So this is what you're going to have. This whole value that you're having here. But they are saying answers only are not acceptable. So they do not want you to do it this way. They want you to do it step by step. And I talked about this. So make sure that you also watch the video about the use of natural logarithms or the use of logarithms to simplify these typical questions that we are given. All right, so this is 4.1. Sorry for that, guys. So I'm just going to write this 4.1. We are given 44,6 to the exponent of 4. Everything is being affected by the cube root. So this was the cube root of 798. So this was 798. Remember, I said you can use the logarithms direct, or you can use the ln, which is the Neperian logarithms. Remember that whenever you see the ln of x, because this is given as x is equal to, so I want to explain this. The ln of x, it is the same as the logarithm of x in the base of e. Whenever you see the ln of x, it is the logarithm of x in the base of e. So you have to be careful whenever you remove your exponents at the end. And like I said, these are just laws of exponents, laws of logarithms that you're talking about. Remember, if you are dividing these numbers, it means before you were subtracting your logarithms, whether there's a log here, it's one and the same thing. You were multiplying these numbers a and b. Remember, I said this was taken from the addition of the ln of a or the log of a to the log of a b. There is a number that is affecting or multiplying a log of a. What was happening with this? It was taken as the ln of a to the exponent of n. So you can have it as a reverse on this other side like this, to the exponent of a, n ln of a to the exponent of n is same as n the ln of a, which is the log of a, just like that. This is what you just need, guys. As long you're given this type of a question. So what do? You introduce your log. But before you introduce, take note of these cube root and write them as exponents, because we can get rid of the exponents. So write them as exponents. So meaning to say this can be rewritten as x is equal to 44,6 to the exponent of a 4 like this. Everything over. Remember from your laws of exponents, all right, x to the exponent of 1 over n, it means the nth root of x. So the nth root of x, if there is a number here, it means it was 1 over that number inside of the root. So this is the cube root. So it means there is a 1 here. So this was 798 to the exponent of 1 over what is inside of the root, 1 over n, 1 over 3. If you have this, as long your terms, as long your numbers are being raised to the exponents like this, do not worry. Introduce your logarithms. So in this case, you are going to introduce. So take note, is something that is not there. your logs. So it's either you introduce it as a ln or as a log. So let me just introduce as a ln. I'm going to introduce another one as a log so that you see that it's one and the same thing. Remember what I said. This is a single part that you're having. But as a single part, it is being affected by laws. The moment that a log is given, the laws must be applied. That is which laws? That is the question now. You are dividing what was it that was happening when these numbers were being divided under a single log. It means the logarithms were being subtracted. The logarithm of what is in the numerator to what is in the denominator. So meaning to say the ln of what is in the numerator minus the ln of what is in the denominator. That is the idea there. This is it, A over B. This is your A, this is your B. You're having two things. You consider the numerator like this. This is your numerator, this is your denominator. That's the idea. This is your A, this is your B. So with this information that we are having, we can use the law. Remember at this condition that if there is an exponent, we can drop this exponent to multiply the logarithm. So the ln of x is same as we drop this number to multiply the log. So it's going to be 4, the ln, or which is the log of 44,6 minus, we drop this exponent, which is 1 over 3 to multiply the ln of 798. That is the idea there. So with this, we can simplify on our calculator stage by stage. That is why they're saying you're not supposed to use your calculator direct, but at this stage, you can use your calculator to simplify as long these are separated without exponents. They're just direct logarithms being added. You can use your calculator at that stage. All right, I talked about that. Make sure that you watch the introduction, guys. Like I said, my calculator is already fixed to 3 decimal places. So our answers are going to be 3 decimal places. 4, the ln, which is the ln, this one, 44,6. You close the bracket. So this is 15,191. 15,191 minus a third of log. This is ln, which is 1 over 3. All right, that's 1 over 3. The ln of 798, close the bracket. So this will be 2, so that is roughly 2,227. Sorry for that, guys. I just opened this by mistake. 2,227. So this is what we have there. So with this, we can subtract. All right. So meaning to say the ln of x is going to be equal to, we simplify this. On our calculator again, that is 15,191 minus 2,227, like this. So this was going to give us as a decimal, that was going to be 12,964. All right, so that's 12,964. So I want us to understand this, to find x, because what we need is to have x. The same x that we are given, we need to find that same x. But in this case, remember I say, whenever a ln is being used, it means you're working with a logarithm in the base of e. So if you are working with a logarithm in the base of e, how are we going to determine x if the ln that we are seeing here is the same as the logarithm of x in the base of e? It means the logarithm of x in the base of e is equal to this number that we are given, which is 12,964. We just removed the ln x, log x base e. So how do I find x? X from our logarithms, it is going to be taken as e to the exponent of this answer. Remember, how do you remove from log form to exponential form? We talked about that on the introduction also. So make sure that you watch that video. All right, so that means our x is simply going to be e to the exponent of 12,964 if you use this Napierian logarithm. So on top of the ln, if you check on your calculator, that is where the E is on top of your calculator here. On top of the ln, that is the E. So it's shift E, the answer that you calculated, that is your answer there. So approximately that was going to be this value that we are seeing. It is because of those rounded off figures that we had previously. So whenever you have these rounded off figures, it means your answer at the end is going to be affected also. Your answer is going to be affected. So this is going to give us, we saw that was 40. All right, 4267769,784. So this is what you're going to have at the end. So this is the value that you're having to 3 decimal places from the rounded off values that we're using, which is approximately on that answer that we calculated before. So like I said before, we could have used the logarithms. So in place of this ln that we are having here, we could have introduced this as a log. Still, we're going to have the same thing. All right, no problem. I'm just going to write this. So this was x is equal to, so you could have written this as a log and also as a log, meaning to say the same laws, the logarithm of x is equal to the same thing. You are dividing the numbers, you subtract the logarithm, so it's the logarithm of 44,6 to the exponent of 4 minus the logarithm of 798 to the exponent of a third. We are back. The ln is a log. So if the exponent, you drop again the exponent, so it means the logarithm of x is equal to 4. The logarithm of 44,6 minus 1 over 3, the logarithm of 798. You drop the exponent. Then you simplify just like the previous case that we had each and every part on the logarithm. So it means the logarithm of x is going to be, so you're going to see that they will be, okay, let us just do this so that you just see it on your calculator. For the logarithm of 44,6. So this is this is going to be 6,657. All right, 6,597. Sorry for that, guys. 6,597. All right, then you're going to have minus a third log of this. So it's a third 1 over 3. That's 1 over 3. All right, the logarithm of 798, like this. So this is going to give us 0,967. 0,967. So the logarithm of x is equal to the difference that we are having here, 6,597 minus 0,967. So this is going to give us 5,630, 5,630, which is simply 5,63. So in this case, you are going to see that to find the value of x, we are no longer having E, which we had from the ln of x. No, this is not the ln of x. This is the log of x. So if the log is given and the base is not indicated, it means you are in the base of 10. So to find the x, this one, it is going to be equal to 10 to the power of the answer. So that is going to be your x. So meaning to say 10 to the exponent of the answer, or simply here on your calculator here, on top of a log, shift 10 to the exponent of, it's one and the same thing, or 10 to the exponent of direct, right? So shift this to the exponent of 5,63. What are we going to have? Still the same answer as the previous one that we had. So meaning to say, this one is going to give us 4,265. That was 4,26579,519. All right. So this is what you're going to have at the end. So you are supposed to be very, very careful in your simplification. You're just gonna work with different questions, try to simplify different questions. That is the best in your simplification. All right, so that was our question 4.1. As you can see, we had different methods to use, or different ways. I mean, not methods, but different ways. Like you can use a log, or you can use a ln. On 4.2, calculate the value of, you are given the logarithm of 243 in the base of x, which is being multiplied to the logarithm of 64 in the base of x. All right, everything is over the logarithm of 32, the base of x, times the logarithm of 81 in the base of x. So this is what you're given. Calculate this value in the base of x, meaning to say the base is the same. That is what they're trying to say. To show you this is to mean that the base is the same. Okay, remember we had this situation of having this condition where I said, if you are given, let's say, log 2 base 3, let's say there's a number here over maybe 4 times. Also, there's log 2 base 3. Remember these types of questions. When the base is the same, you can simply cancel this. Like there's log 2 base 3, log 2 base 3. Everything is the same here. So you can actually cancel this and you remain with what? 3 over 4. So what am I trying to say is that given the base of x like this, let's say I've got a number like 3, the logarithm of 4 in the base of x like this, over 7, the logarithm of 4 also in the base of x. As long I have 4 base x, 4 base x, I can cancel 4 base x, log 4 base x, log 4 base x. I remain with 3 over 7. So this is exactly what we can think of. But in order for us to have this in simplification, try to use numbers in simplest form. 243, 64, 32, try to write these numbers in simplest form, that is as prime numbers. Prime numbers, we are talking about 2 exactly divisible by 1 and itself, 3, 5, 7, and so on. So these are the prime numbers that you try to work with. All right, so this is what I'm trying to say. On your calculator, you just going to have this. All right, so remember our calculator was being fixed, so we have to change it to the normal mode. That's press shift, set up, then 8, then press 2. All right, so this is what you try. 243. There I can't try 2, guys. To get 243, guys, there is a 3 there. A 3, a 3, a 3. So meaning to say 2 cannot work. So you try a 3, 3 to the exponent of 1 to the x until you get 243. So you're going to see that you're going to get this at 3 to the exponent of 5. So you're going to try like this, 3 to the exponent of 4. You see that like this, 3 to the exponent of a 4 like this, you obtain 81, which is not this one. 3 to the exponent of a 5, you obtain 243. So meaning to say this can be written as 3 to the exponent of 5 is 243. We go to this 81, we saw that 3 to the exponent of 4 is 81. The same thing with the 64. We can't use 2 there. We can't use, 3. We have to try 2. 2 to the exponent of what? 2 to the exponent of 6. So is it you try to the exponent of 1 until you get this 64. So this is how you're going to work out this question. So in this case, 243 in simplest form is the same as log 3 to the exponent of a 5 in the base of x, multiplied to 64 in the simplest form, that is 2 to the exponent of 6 in the base of x, divided to 32 when written in the base of 2, the simplest base, which is 2, it is 2 to the exponent of a 5 in the base of x, multiply to 81 in the simplest base, which is the base of 3. 81 is 3 to the exponent of a 4 in the base of x. Remember I said before, if we are given an exponent, multiply that to a log. Whenever there's an exponent multiplies the log. So meaning to say, I'm going to drop this exponent. That means if I'm given n, the logarithm of a, this is the same as the logarithm of a to the exponent of n. If I'm given it as an exponent, I'm going to drop it to multiply the log. So this can be dropped to multiply the log. That means I'm going to have 5, the logarithm of 3 in the base of x, times, drop the exponent, that is 6, the logarithm of 2 in the base of x. So this is, you drop, so this is the logarithm of 2 in the base of x. Everything that we are having, we do the same thing in the denominator. There is a 5, drop this, so that is going to be a 5, the logarithm of what? Of 2 in the base of x. The same thing on this 4, we drop it to multiply the log, so that is 4 times 1, which is 4, the logarithm of what? We are given the logarithm of 3 in the base of x. That is the idea. You drop these exponents. So by doing so, we can cancel as long it is the numerator, denominator, and they are the same. 5 and 5, we can cancel. The logarithm of 2 in base of x, the logarithm of 2 in base of x. The logarithm of 3 in base of x, the logarithm of 3 in base of x. So you're left with 6 over a 4. So 6 over a 4, if we divide this, that is same as 3 over 2 in simplest form. That is the idea there. So meaning to say, we can actually use our laws of logarithms to simplify these typical questions. All you just need is to be very, very careful. You need to be very, very careful in this simplification. All right, let us consider another part of our question, which is actually on the exponents and log is actually solve. Solve for x on 4.31. So there we are given 3 to the exponent of 2x minus 1 times 9 to the exponent of x minus 3 is equal to 27 to the exponent of nx. I always say when working with the exponential equations and the unknown is on the exponent, like what we are seeing here, the unknown is on the exponent. It is always best that we write in the same base, x to the exponent of a, if it is equal to x to the exponent of b. I say that whenever this happens, that the bases are the same, simply equate your exponents. So therefore, it simply means a is equal to what? Therefore, a must be equal to b. Automatically, as long these bases are the same, it follows that these exponents must be the same. So in order for us to do that, we must write these bases in the simplest base. And the simplest base is a prime number. Why a prime number? A prime number, guys, it's a beautiful number, a prime number. It's a number that you can't there are no factors. It's just that number and 1. That's the advantage of a prime number. 2 is just 1 and 2. 3 is just 1 and 3. 5 is just 1 and 5. There's no other factor there. So that's the best way of working with what? With prime numbers, because there is no other factor that can be considered. So the question is 3 a prime number? Yes, it's a prime number. So it's already in simplest form. So there's nothing that we can do. Okay, is 9 a prime number? No, it's not. Can it be written as a prime number? That is the question. Can 9 be written as a prime number? And which prime number is that? That is a 3. 3 to the exponent of 2 is a 9. So that is 3 to the exponent of 2 to the exponent of x minus 3 is equal to 27. Is it a prime number? No, it is not. Can it be written as a prime number, which is 3? Yes, that is 3 to the exponent of 3. So meaning to say I've got 3 to the exponent of 3 times this x, which is already there on the exponent. So 3 times x, that is going to be 3x. So before we do any simplification here, Let us see what we are having on this part. Remember that an exponent to an exponent, you have to multiply x to the exponent of a to the exponent of b is same as x to the exponent of ab. So meaning to say these two, he has to distribute everything inside. That's 3 to the exponent of 2x minus 1 times 3 to the exponent of 2 times x, which is 2x. 2 times minus 3, that is minus 6. This is equal to 3 to the exponent of 2x. All right. This is 3 to the exponent of 3x, sorry. With this part, we can combine this to be a single number. How? Remember that if the bases are the same and you are multiplying like this, you are going to add exponents. So they were simply adding 3 to the exponent of 2x minus 1 plus 2x minus 6. Remember addition. There's no need for us to have the brackets. So 2x plus 2x, that was going to give us 4x minus 1 minus 6. So this is going to give us minus 7. Minus 1 minus 6, that is minus 7 on your calculator. This is 3 to the exponent of 3x. Why simplifying all this up to this stage? What we need is a single term equated to a single term. A single term to a single term, just like what we are having here. A single term to a single term. Once this occurs, you are going to equate the exponents. The base of 3 is the same as the base of 3 here. So what does it mean? It means also the exponents are the same. So therefore, it means 4x minus 7 must be equal to 3x, which is a linear equation that I can solve by transposing 3x to the left-hand side. That's a negative. So that will be 4x minus 3x is equal to transpose the minus 7 on the other hand. It was a negative. The moment it crosses the equal sign, it becomes a positive. So that's it. 4x minus 3x, that is x, which is same as 1x is equal to 7. But 1x is same as x. So it means x is equal to a 7. That's the idea. So you are supposed to be very, very careful in solving of these typical equations as long you are working with the exponents, as long you are working with the bases which are the same. If the bases are the same, what are you going to do? That is the question. The bases are the same, so you're going to equate the exponents. All right. Number 4.32, again, it was to solve for x. And there's 3 marks, and this time it's a logarithmic equation. 4.32, the logarithm of 1 over 64 in the base of x is equal to 3. Remember that this part can be taken from the introduction that we talked about from a log form to an index form. The logarithm of a in the base of b, if it is equal to c, it follows that this a is equal to b to the exponent of c. Remember, we talked about this, the ABC concept. So this is your a, which is the 1 over 64. So 1 over 64 is equal to the base to the exponent of what? Of 3, which is x to the exponent of 3. So the question is, x is already on the base. So how do we remove the exponent of 3, which is affecting this x? That's the question. How do we remove this? How can we remove these 3? So the 3 that we are seeing here is same. We can remove it by writing to the exponent of a third, which is the reciprocal, the inverse of a number that you're given, which is 3. The inverse of a number is 1 over that number. If I'm given a 3, that the inverse of a 3 is 1 over 3. Why? It follows that a number times its inverse gives us a 1. So that's why we have to opt for the inverse of that exponent that we're given, because the moment we raise this to the exponent of a third, which is the inverse of 3, it is going to be 3 times a third, which is a 1. So I'm left with x to the exponent of 1, which is simply x. That's it. X to the exponent of 1 is x. So x is equal to 64 to the exponent of a third. But remembering, guys, 1 over 64. Wait, are we having this? 64, it is same as 2 to the exponent of a 6 to the exponent of a third. So this is x is equal to, remember 1 over, I talked about this also on the introduction. Whenever you are given a 1 over a certain term, this was taken from a negative exponent. So 1 over 2 to the exponent of 6 was taken from 2 to the exponent of a negative 6, being raised to the exponent of a third. We are now back to the law of the exponent to the exponent. How do you simplify this? An exponent and an exponent. How do you simplify this? So that is x to the exponent of 2 to the exponent of minus 6 times a third. You multiply minus 6 and a third. That was going to give us a negative 2. And remembering that, how do we remember here? It was 1 over, and we wrote it as a negative. So you can also do the vice versa to remove a negative exponent. How do you remove a negative? It's 1 over 2 to the exponent of 2. So this is equal to 1 over 2 to the exponent of a 2, that is a 4. So meaning to say at the end, we were going to obtain 1 over a 4. This is all about the laws. The laws, it's all about the laws if you check properly. And the disadvantage is that you do not have these laws in your formula sheet. So you need to take your laws of logarithms, exponents to the heart. You need to know them by heart. So these are the typical questions that you're given. We shall work with these typical exam questions as we are done with our introductions. So make sure that you do the right thing by subscribing to this channel, Maths Zone African Motives, for more questions like this. Till we meet again.